So now we'll start studying about pulse code modulation, its transmitter and so on. We have seen what is quantization, we have seen what is sampling. Now we'll understand how we are going to encode and quantize the signal. So now we'll see what is encoding in PCM. We have seen what is sampling, we have seen what is quantization. We have seen two types of quantization. In non-uniform quantization, there are some problems based on A law and mu law, which is uploaded. You need to practice these problems also. Now what we are doing is that after we have done that quantization here, this part is called as encoding. Okay. First, the analog signal is passed through a low pass filter so that high frequency components are eliminated and only the required bandwidth is allowed to pass through. Then this is what is called as PCM transmitter. That means we are generating a pulse code modulated signal. Pulse code modulation is a very important concept in which we are doing three important things. One is called as sampling. We have a sampler, sample and hold, very easy. We have seen what are the different types of sampling and how sampling is done. Then quantization, then it is encoded. The symbols generated is then encoded. After encoding, what we get in the output, we get PCM signal. Then it passes through the channel where we have regenerative repeaters. A very common question in your examinations is that what is the need for regenerative repeaters in PCM receivers? It's a very common question. We have regenerative repeaters. We'll see what it is as we go on. Here we are doing the encoding, and here this is analog to digital communication. In the receiver end, we are creating analog signal from the digital signal. We are decoding it, and then again we are using a reconstruction filter, and here you will get the analog signal output. This is a basic fundamental block diagram of a pulse code modulation system. You have a transmitter, you have a receiver, you have regenerative repeaters, you have encoding in the transmitter end, you have the decoder in the receiver end. So how encoding is done in PCM? Although in the output of the quantizer you get a set of symbols or digital values, it is not fit enough to get itself transmitted. For that we use or we do encoding. Why do you need to encode a signal, a quantized signal? Because the signal that is quantized is not ready for transmission. There are certain things it has to be done so that it gets itself prevented from the interference, noise and other problems that happen when it is getting transmitted through a channel, or these things has to be taken into consideration. So you need to encode a quantized signal, and this could be a very common question in your exams. They might ask you, why do we need to encode a signal? We need to encode a signal because the quantized signal is not fit enough to be transmitted. It needs to get itself eliminated from the noise, other interferences or any other problems that the channels might create. So we make the signal encoded, compressed enough so that it is fit to be transmitted. So I hope you guys are clear with why do we need to encode a signal, right? 3 steps in generating a pulse code modulated signal. First one is sampling, second one is quantization, and the third one is encoding. We have different forms of encoding such as binary encoding and so on. We'll see these things in detail as we go on. So in order to eliminate or reduce the effect of noise, we use binary encoding or binary coding system, in which we have binary means you have zeros and ones, you have two zeros and ones binary system of encoding. We'll see what is binary system as such in detail in the coming slides. Now we are using binary encoding very commonly because it is highly resistant to noise, and another advantage of binary encoding is that it can easily be regenerated. What are the two advantages of binary encoding in pulse code modulation? This could be a question in your exams. Two advantages. First one is highly resistant to noise, and the second one is that it is more easy to regenerate. Is it clear, all of you? So why do we need regenerators? Most important feature of a the most important feature of pulse code modulation is its ability to withstand noise or reluctance to noise. And how is this attained? We need a set of regenerative repeaters. This was a question that came in your university exam in the last or the previous exam. Why do we need regenerative repeaters in pulse code modulation? So we have a series of regenerative repeaters. You might have seen in the block diagram that you have 1, 2, and so on between the transmitter and the receiver. Right? Set of regenerative repeaters. Okay. The set of regenerative repeaters or the chain of regenerative repeaters help the pulse code modulated system to avoid noise. So how is noise reduced in PCM? Or what is the need of regenerative repeaters in a pulse code modulated system? All these are probable questions that might appear in your university exams. So let us see what are the functions of a regenerative repeater in PCM system. We have a series. In this we have three important basic functions. One is equalization, another one is timing, and third one is decision making. So this is the distorted PCM wave, and from here we get the output regenerated pulse code modulated wave after performing these three functions. So what are the functions of each of these three important blocks? We have an equalizer, we have a timer, timing circuitry, and a decision making device. What are each of these doing is explained here, very easy, simple words. Okay. So as discussed, we have three important components of a regenerative circuit. First one is the equalizer, second one is the timing circuit, and the third one is the decision making device. In the first part, equalizer, what we are doing is that we are compensating the effects of distortions, amplitude and phase distortions. So, equalizer compensates for the amplitude and phase distortions. Okay. Then we have the timing circuitry where we have periodic pulse trains, and we'll be analyzing based upon the threshold level. We have a threshold level. Above that, if the values are coming, we'll make a decision that this is this side and the other one is the other side. Okay. That is how we classify the signals. So in each bit interval, a decision is then made on whether the received symbol is 0 or 1 based upon the threshold value, whether it is above the threshold or below the threshold. In this way, what we can do is that we can eliminate or we can reduce signal distortions. So we'll see. So what are the disadvantages of using regenerative repeaters in PCM? We have two important disadvantages. Although the signal is original as what it is being transmitted, so we have two disadvantages or drawbacks of using regenerative repeaters. This could be a question in your exams. What are the drawbacks of using regenerative repeaters? Although we have the same signal as the transmitted signals, we have a small change in time. First point. Second point is that although there is a whatever we do, however we try to restrict, we'll be having some channel noise, right? And interference. So sometimes what happens is that the decision making circuitry could be wrong and there could be some errors occurring. Okay. So that errors are called as bit errors. So the possibility of bit errors are still there even while using regenerative repeaters. And there will be a jitter, as I told you, there will be a time delay from the original signal. That is called as jitter, and that will be creating a small change in the pulse duration in the entire signal, which could, of course, obviously be corrected in the receiver's end. So what are the noises that might occur in a PCM system? So we have two kinds of noises that appear in a pulse chord modulated system. First one is called as the channel noise. Channel noise is the noise that is being introduced after the signal is being transmitted and at the point where the signal is being received. Okay, as long as it passes through the channel, whenever you have a transmitted signal passing through a channel, you have a noise that is unavoidable, and that noise is called as channel noise. The second one is the quantization noise, which is there within the input signal itself, which is being transmitted towards the receiver. The difference is that channel noise does always exist and quantization noise does not exist when you have no transmission, no signal being transmitted. Even if there is no signal that is being transmitted, the channel and the channel noise is always present. But in case of quantization noise, you don't have that when you don't have any signal being transmitted. Okay, so these are the two types of noise that could appear within a pulse code modulated system. And what are the noises in PCM may be a good question to be asked in your exams. See how many questions are coming. Every slide I told you has a answer to a question. So the next is the pulse code modulation transmitter and receiver system. With a neat block diagram, explain a PCM system. So here we have the message source, and from the message source we have an anti-aliasing filter. Can you tell me what is meant by aliasing? What is meant by aliasing? Anti-aliasing filter. Signal is then sampled and quantized and then encoded, transmitted through the channel and filtered using noise. Then we have regenerative circuits here. We have pulse generating circuits. Along with that, we'll be correcting all the errors. We have a decoder, reconstruction filter, and we'll get the message signal at the end. So this is a transmitter and the receiver block diagram of a pulse code modulation system. There would be a more than 80% chances are there that you will get a question on PCM transmitter and receiver. So thank you all. Thank you for listening to me. The next class we'll see in detail about PCM transmission and reception.